Hi class, today we're looking at Chapter 5, Lesson 10, Indirect Measurements. Our objective is solving problems involving indirect measurements using shadow, reckoning, and surveying methods. An indirect measurement, or measurements, allows you to use the properties of similar triangles to find measurements that are difficult to measure indirectly. So we also use something called shadow reckoning. So with shadow reckoning, two objects and their shadows form two sides of similar triangles. In the diagram below, it shows how two objects and their shadows form two sides of similar triangles. You can use a proportion to find measures such as height of a flagpole. So in this case, we have the height of the flagpole and we can compare it to the height of an actual person. So we could say the height of the flagpole over the height of an actual person is similar to the shadow of the flagpole and the shadow of the person. And by setting up that proportion, we can create a cross product and multiply diagonally. And you also could figure out that it creates a scale factor if you were also to simplify our fractions or our ratios. Go ahead and turn your notes to the backside now. In example 1, we're looking at a school building that casts a 40.5 foot shadow at the same time a 5.8 foot student casts a 4.4 foot shadow. How tall is the school building to the nearest tenth? Now what we do is set up our proportion. So we know that it has a shadow of 40.5 and we're looking for the height. Then we know that the height of the student is 5.8 and their shadow is 4.4. So when we set up our proportion, we're going to compare the height over the 40.5 of our school building, and we're going to set it equal to the ratio of the student. So we have 5.8 over 4.4. Then we're going to use the cross product by multiplying diagonally. So 4.4h equals the 5.8 times the 40.5. Now when we multiply the 5.8 and the 40.5, we get 234.9. We divide each side by 4.4, and we end up with a height of 53.4 feet. So our final height of our building is originally 53.4 feet. In example 2, suppose a rocket outside a science museum casts a shadow that was 176 feet. At the same time, a 5.75 foot tall person standing next to the rocket casts a shadow that is 9.2 feet long. How tall is the rocket? Draw an image to help you find your solution. Now, from this point, we have our rocket ship, which is 176 feet for its shadow. So that would be this part right here. And then the person we know is 5.75 feet tall, and they cast a 9.2 foot shadow. So once we realize that we do not know the actual height of the rocket, that would be our ratio we would set up. So we would go x over 176 equals the 5.75 over 9.2. So it's the actual height of the object or person over the shadow of each. Now we would simply use the cross product to evaluate our answer. So we would have 9.2x equals 1,112. Then of course we're going to divide each side by 9.2. And we end up with the height of the rocket ship being 110 feet. And that would be the height of the rocket. Now go ahead and do these two practice problems on your own. We will check them in class.